Hello everyone, I'm Nathan and welcome to my YouTube channel, Unconventional Engineer. So I thought I'll document some of the works which we have completed so that it may be helpful to some of you out there, especially our tribal engineers from the northeast part of India. So I hope that some of the works which we have done, you'll be able to follow up, understand, and maybe take some inspiration from it also. So before I start, I want to give thanks to three awesome engineers who have been mentors in my life. First of all, Sir Milan Bora, retired Chief Engineer of MECL and also retired Chief Technical Advisor, Government of Meghalaya. Awesome technocrat and very down-to-earth person. I really missed him. Second, Amberlight Lingda also. He has been a great mentor to me, senior engineer and soon to retire engineer at MECL. Very down-to-earth person and brilliant with his concepts also. And third, Kong Velorich Soklet, my aunt and also like my mother, brilliant structural engineer, awesome with how to use spaces and very unbiased and really has a very good perspective of how to go about things. So that being said, I'm very grateful to everyone who has brought me in this journey so far. So what I'm going to start now is I'll start with the Pico Hydel Project, which is Pico means less than 5 kilowatts here in the tea garden in Tasku, Riboy district. So this is actually the second Hydel project, but since this has a simpler sort of layout, compact, I'll start with this so that it'll be simpler to understand, and perhaps in the following videos we can get more idea as to how to go about. So I'll show you step by step how to go. Alright, so as mentioned earlier, I'll take you through the layout of the project, and Tasku being a very compact sort of project, so it's very easy to understand, it's simple. So right now we're standing on top of the building, and of course there are some solar panels around, but right now we are more interested in the Hydel project. So first of all, we have a small dam out here, and this has created a pondage out here, a small pondage. So from here we release the water when required, and this goes to the desilting tank out here. This is the small tank here which soil, sand, it settles down. Then it goes forward, it goes to the forebay, which is the rectangular tank which you see there, and then from there onwards it goes down through the penstock pipe, and if you can see down below, you have the powerhouse below. From there the power is transmitted through the transmission line which you can see here, and then it goes to the domestic supply line for our users. Yeah.
Okay, so we can see the layout of the project here in Google Earth. It's very clear. You can see the earthen dam, the pondage, the desilting tank, the forebay, the penstock, and the powerhouse there. So I'll just turn this around, and you can see very easily how compact and simple it is to understand. So I hope this helps.
Right, so we're at the dam right now. This is a simple earth fill dam. As you can see, this is all just soil, nothing special here, very simple. And this has created the pondage out here. So usually what we do is that we store it during the day and then we release it at night for lighting and other purposes. So it's very simple really. And we have a pipe here. It is right now covered since the water level is slightly high. It is November in the third week now, but you can see the pondage which we have right now is not bad. Yeah, so I'll just show you in the following steps again. So we're at the base of the dam right now, and you can see the dam is out here. It's all soil only, and then we have two 6-inch pipes embedded in the body of the dam. So we have a simple valve out here, you can see here. So I'll just open one of them for demonstration. It's very simple really. Yeah, so the valve is now open, and you can hear the water gushing down now. So I'll show you in the desilting tank now. So you can see the water gushing down now. through the pipe the valve through which I've just opened. So this is the desilting tank now. So we try to reduce the velocity of the water, and you can see the water coming in and then going out slightly lesser, so that the soil particles can settle at the bottom of the tank, and then we flush it out. So this is a simple setup, and then from there onwards it goes through this nala. It's just a simple small 1 feet nala, and then it goes forward. Alright, so this is the 4-bay now, and this is slightly bigger. We have designed it in such a way that it can take into account, say, around 10 minutes of runtime in case of any emergency. There's that for the powerhouse. So this is quite sufficient. It's small, but our turbines also are really small. So as you can see, this is the water coming in and the water going out through the overflow, and the penstock pipe is below. Alright, so the penstock pipe is below, and we have two 4-inch GI pipes which are there below, and from there it comes here. So you can see these are the valves coming from the penstock, and this is called the air vent pipe. So what happens in the air vent pipe is that air which might be stuck in the penstock pipe, it might block the flow of water, and we need to release it. It's something like your air locking mechanism which you have in your vehicles. So the level of this one is slightly higher than the level of the 4-bay, so that allows the air to get released from here. So I'll show you along the penstock. So we are at the base of the penstock, and you can see the penstock line coming up from there, and from here we have the powerhouse. So your total head, which we say, from the 4-bay till the central line of your turbine here, is 15 meters in this particular project, and the discharge will be around 6 liters per second. So it's really small. It's just 4-inch pipe, which means 100 mm. So these are also locally got turbines from my good friend Mr. Ming Azung from the Dimapur, Nagaland. So what they do is that they have made these are 3 kilowatt installed capacity turbines. These are turbo impulse turbines, and very simple setup really. So this is the main inlet valve, which we say. So you open this one, it spins the turbine, and then this is a permanent magnet generator. So from here this comes to this is the electronic load controller, or ELC, which we say, and the dummy loads are very simple. As you can see, they are just simple bulb lights, 100 watts each. So some of the bulbs have been damaged. So right now we're just using 6 bulbs, and around about the power which is generated is also around 600 to 700 watts only. So it's very tiny. So mainly used for lighting needs only. So it's very simple here, and then sometimes it gets really hot due to dummy load. So we have made sort of a ventilation system out here. So it's just that it's a really small space and compact and very simple. And the discharge from here, you can see it'll be coming out here. So it's very tiny really. So I'll be starting the turbine now, and then I'll call upon the operator here, which I've left in charge, my good assistant Anal Sama. So he'll start the turbine. You can say hi. So he'll start the turbine, and then we'll see how it functions. Yeah. The frequency is as it is in India, 50 hertz, and the voltage 230 for domestic line only. So we are releasing the valve now. So you'll see the dummy loads coming up here. The lights will be flashing out here. Yeah. Right, so it's now fully open, and the dummy loads also are fully on now. So you can see the frequency which is given here. So this is 50 Hertz. It's trying to bring it back to 50 as much as possible. The voltage is not displaying right now, but it is 230 volts only. And from here, this is the NCB which we sent for using. So I'll not put this on right now, I'll just put it off. And we can see the discharge coming out from here is really tiny, you can see. So you can see it's really a little bit of water only which we're using. And it's amazing what a little bit of water can do with a little bit of height which you have. So you can generate the power which we can use for, I think how many? We're using for 15 rooms maybe, which we're using for lighting and mobile charging purposes. So it's really awesome. And then we have this kind of storage system which we can use it anytime. So thank you for watching, and if you have any questions or queries, you can put in the comments, and do continue watching my videos. Thank you.